So I'm going to be announcing our final plenary lecture, and after the lecture, don't leave right away, as there'll be some brief concluding remarks that I wouldn't want you to miss for the world. They'll be just fascinating. Don't leave. It's like stay through the end of the credits. Okay, so our final plenary lecture today will be delivered by Seana Coulson, who I'm sure is known to all of you. She's an associate professor at UC San Diego and also the director of the Brain and Cognition Laboratory there. She was also the organizer of the previous CSDL. And thinking about this and also some of the topics of Seana's research on humor makes me think of the classic quip about Fred Astaire and Ginger Rogers, that Ginger Rogers is actually a better dancer because she does everything that he does only in high heels and backwards. And having just gone through the wonderful and yet somewhat demanding process of being a co-organizer of CSDL with two extremely capable co-organizers makes me realize that Seana has done what we have just done, only by herself and with mariachis. So I'm very impressed. So Seana's work pulls mental spaces and conceptual integration out of the armchair and into the laboratory. She uses an array of methodologies to study some of the trickiest and messiest aspects of meaning construction, like humor, like metaphor, political rhetoric. They're fascinating and they're difficult, and fortunately we have Seana here to not be afraid of them, and to use a whole bunch of different methodologies from discourse analysis, reaction time studies, neuroimaging, to study these aspects of meaning construction from every angle, and to subject them to her rigorous and inventive analysis that is really great for all of us who are interested in these complicated and difficult aspects of meaning construction, but also extremely fun ones that we would hate to neglect. And Seana's talk today is titled Gesture Comprehension, and I hope it still is, yes, Gesture Comprehension and the Space Structuring Model. So please join me in welcoming Seana Coulson. Are you on?
I don't know. Okay, good. All right, well, thanks for the kind words. Yeah, I mean, Gilles has this metaphor for cognition, or for language comprehension, talking about sort of the iceberg. And so the linguistic string is the tip of the iceberg, and then the conceptual activity is sort of the 9/10 that are underwater. And I know from organizing the last CSDL that, you know, going to the talks is sort of the tip of the iceberg, and then there's a lot of background cognition that involves interplay with administrators and so forth, and begging for money and things like that. So, you know, how about a quick round of applause for our wonderful bottom of the iceberg, Vera, Faye, and Mark. All right. Yeah, so every Olympics, at the concluding ceremonies, they say, and this is the greatest Olympics ever. And I remember after the Sydney Olympics, they said, yeah, every year they say this, and this time it was actually true. So, you know, Cleveland is the Sydney of CSDL. So. Okay, so I want to talk today about actually a very straightforward phenomena in contrast to some of the gymnastic ones I've looked at in the past, which is just co-speech gesture. Okay, so I'd like to start with this quote from Lanneker, which is, when a novel expression is first used, it is understood with reference to the entire supportive context. The speaker relies on this context, being able to code explicitly only the limited, even fragmentary portions of the conception he wishes to evoke. Usually then, the expression's conventionally determined import at best approximates its actual contextual understanding. It does not contain or convey the intended meaning, but merely furnishes the addressee with a basis for creating it. And this is my starting point because it's sort of the fundamental feature of language, in that the linguistic input really only gives you a small portion of the information that you need to construct the fully blown meaning. And so I'd like to talk about some of the other sources that come from the context of its use. So the approach to language comprehension that I pursue in my lab, I call the space structuring model, with deference to mental space theory. And it's basically inspired by work by cognitive linguists such as yourself. And the basic idea is that Language prompts the construction of cognitive models, or construals, in working memory, via all sorts of information in the context, some of which is provided by the language input. I mean, this is really important, but also the social context, your current cognitive state, and perceptual information that you're drawing from the world around you. Okay, and the research in my lab is sort of motivated by this philosophy that we should be studying language in the wild. And cognitive linguistics is a usage-based approach, so the features of language come from the fact that it's used in particular kinds of contexts. And I want to talk about one aspect of language in the wild that you can see just looking at these pictures of people using these things, which is co-speech gesture, or the fact that we tend to move our hands and other parts of our body as we're talking. Okay, so in studying language in the wild, we began our endeavor into this in the wilds of Oregon. Okay, and so I want to show you a portion of a video clip that was taken by one of my former PhDs, actually my only PhD, and current postdocs, Ying Wu. Okay, and so this is a video from some friends of hers in Oregon, and they're engaging in some Oregonian activities of beer drinking and storytelling. Okay, so we'll.
Alongside him, and the snake was right here, and his head was back like that. And alongside him, and the snake was right here, and his head was back like that. And
so he says, walked up alongside him, and the snake was right here, and his head was back like that. And just for fun, I'll show it to you one more time.
Alongside him, and the snake was right here, and his head was back like that. And
right, so it's pretty clear from seeing the video that the gesture is providing a crucial input to the meaning construction process. And that's sort of the starting point that I'd like to work from today. Okay, and so with respect to gesture comprehension, I just want to point out that I'm using Verhagen's model from his 2005 book on constructions, that all language comprehension involves activity both at the object level, where the stuff you're construing is sort of the focus, but also at the subject level, where these would be the interlocutors in the discourse and the fact that they have to establish rapport and common ground. And I'll be focusing on the contributions of gesture to this objective level of conceptualization, but a lot of what gesture does is actually at this level of the subject of conceptualization and the establishment of common ground and the establishment of rapport and so forth. And there have been a number of talks at this meeting. My favorite was, there was one that was on lying and the gestures that people make when they're lying versus telling the truth. So just a shout out for that one. Okay, so the particular issues that I'd like to address today have to do with, first of all, the real-time processing of iconic gestures, whether people treat co-speech iconic gestures as meaningful contributions to the discourse. I'll also be addressing the question of whether speakers integrate gestural information with linguistic information. And in particular, are they integrating gestural information with the information that's presented in the accompanying speech? And just what is the nature of that integrative process? And then finally, I'll look at some new data where we address whether the presence or absence of gestural information affects the real-time processing of speech itself. Okay, and so using this constructivist approach that I'm advocating, the space structuring model, my basic question is whether or not gestural input is a contributor to this meaning construction process along with these other information sources. And of course, so with the first set of studies I'll be talking about, I'll be asking the question whether gestures are processed semantically and whether people integrate the semantic content of gestures with preceding non-linguistic context. Okay, and so the question of whether gestures are treated as meaningful information kind of depends on what kind of gesture you're talking about. So beats are sort of these rhythmic movements that speakers will make that tend to coincide with prosodic high points in the utterance. And there's probably some component of meaning probably at the S level in Verhagen's model, but they're not really what we would think of as meaningful. Emblems, on the other hand, are gestures that have sort of a conventionalized meaning associated with them. So it's pretty clear that this kind of a gesture is actually meaningful. So I'm actually more interested in these iconic gestures, and these are gestures that signal visuospatial relationships. So if somebody says, I caught a fish and it was this big, you could consider that an iconic gesture, or it's right behind the other building where you use your hands to display the relative location of two objects. That would be an iconic gesture. And this class of gestures has been somewhat controversial as to whether speakers actually are taking in the meaning that's being conveyed by those. Okay, and I find these gestures interesting in virtue of their position on a semiotic continuum. Okay, so if you think about meaningful bodily action, at one end of the continuum, there's action. So if I'm dunking a basketball, the meaning of that action is just dunking the basketball. There's no representational content to it. It's meaningful in virtue of what it actually is. On the other hand, we have deictic gestures, and this is a movement that's meaningful in virtue of the context in which it's made. There's also emblems that we discussed before, and this is the crazy sign where you're going like this. So this is, I don't know that that's really what he's doing, but in the Google image search, it says, Muhammad Ali does the crazy sign to President Bush. And then this one is raise the roof. It's hard to tell. They just look like they're dancing in some of those. Okay, and then there's sign language, where you have a fully formed sign system, where there's conventional meanings for each of the gestures, and there's rules for combining them, and ways for deriving larger meanings by combining simpler ones. Okay, so iconic gestures are interesting because they're sort of midway on this semiotic continuum, with action on one side and then maybe sign language on the other side. Okay, they're interesting for semiotically because, first of all, you can have similar forms mapping to different meanings. So here we have our speaker, our favorite informant, talking about this picture of gum. And here we have kind of a similar configuration of the hands, and he's actually talking about this lounge chair. So kind of similar forms mapping to different meanings. And we also have the same meaning mapping to different forms. So in this clip, he's talking about stripes, and his hands are in this configuration. Here he's also talking about stripes, and his hands are in a very different configuration. Okay, so in the past, with respect to this question of whether or not listeners interpret the iconic gestures that are produced by their interlocutor, there have sort of been two schools of thought. So one school of thought, advocated by, say, Krauss, assumes the position that gesture is actually epiphenomenal to the speech production process. So in this case, gesture is important for the speaker, but not necessarily for the hearer. So for the speaker, producing the gesture would help with lexical access processes, and it supports their encoding of the information, but that listeners don't really derive that much information from these things. On the other hand, you have a lot of gesture researchers, most notably, say, David McNeil, that say that, actually gesture and speech arise from one underlying conceptual process. And of course, gesture is important for the speaker, but it's also important for the hearer. So it's important for the speaker because the gesture and the speech production process are actually interrelated. You have one sort of thought that's going to get expressed through these different modalities. And for the listener, information from the speech and the gesture is going to be integrated in order to sort of form a greater conceptual representation. Okay, so just to give you a flavor of what different advocates have said, so Krauss says, it may be that much of the gesture's meaning is illusory. In the absence of speech, the very same gesture's meaning can be quite opaque, communicating little, if anything. Or Adam Kendon, descriptive gestures, rather like drawings or pictures, can achieve adequate descriptions with much greater economy of effort and much more rapidly than words alone can manage. Okay, and so this question, as you might think, has been addressed by a number of previous studies. And actually, there's evidence that supports both points of view. So some studies have suggested that actually gestures really do only help the speaker and not the listener. And other studies have suggested that, well, it does seem that listeners are taking in this information conveyed by the gestures because their subsequent discourse seems to reflect information that was conveyed in the gesture and in the speech. It kind of depends on the topic of conversation. Okay, but most of these previous studies have actually looked at the impact of gestures on how people dealt with subsequent discourse. And so we said, well, we want to look at what's happening when people are actually processing the gestures themselves, or the real-time processing of the gestural information. So we wondered whether or not iconic gestures were processed semantically. And to address this question, we decided to use the technique of event-related brain potentials, or ERPs. And so this is a technique where we put electrodes on your head. So these are EEG electrodes, just like would be administered if you had an EEG test in the hospital. But we do different kinds of data processing than they would be doing there. So this gentleman has had one EEG electrode applied to his scalp. Any resemblance to Dr. Bergen is completely coincidental. And so what you do is you convey a stimuli, like this guy's listening to a beep, and you record their ongoing EEG signal. And to any given stimulus, this is the sort of response that you get. It's just sort of an oscillatory response. But if you convey the same kind of stimulus multiple times and then average the traces that you get to each stimulus, what happens is that the electrical activity that's not temporally coordinated with processing the stimulus is going to average out, and the electrical activity that is correlated with processing the stimulus is going to remain. So you end up getting a trace like this, which is, it's still just a series of positive and negative peaks, but each of these peaks has been correlated by cognitive electrophysiologists with different kinds of sensory and cognitive processing. And so one way of seeing this is that the line is totally flat here before the stimulus happens, and then the activity begins after the stimulus. So, there's no brain activity correlated with the processing of this beep before it happens, so the ERP line is flat. Okay, and we're going to be concerned with a particular kind of language ERP effect that's been correlated with semantic aspects of processing, or the N400, which is one of the best-known semantic or best-known language ERP effects. So it's called N400 because it's a negative going potential, and the 400 refers to the number of milliseconds after which the stimulus is presented that it sort of peaks. And in the graphs that I'll show you today, we plot voltage on the y-axis with negative voltage plotted up by convention, mostly because we're very interested in this N400 wave. And then time unfolds on the x-axis. So you get a picture of the electrical signal changing over the course of time as the subject processes the stimulus. Okay, and so here we have a larger N400 evoked by sentences that end with sort of a less expected meaning than sentences that end with a more expected meaning. So the N400 is understood to be sort of an index of lexical integration processes. With it being larger, the more difficult it is to integrate a word into the established context. And more importantly, it's an index of the processing of the meaning of an event. So if we can see an N400 evoked by iconic gestures, then we can say, well, okay, that's a good suggestion that maybe semantic processes in the brain are being invoked to understand this stimulus. Okay, and you can see this by the kinds of experimental manipulations that change the size of this brain component, this ERP component. Okay, so word class N400s are evoked more by content words than by function words, so more by nouns and verbs that convey referential content than things like articles that really don't. It's larger for contextually incongruous than congruous things. And in fact, there's sort of a tight correlation between the size of the N400 and the degree of expectancy, with it being larger for unexpected events than for expected events. So if you have a sentence and if you have one sentence and the last word is produced by 100% of the people, it's going to have, well, if you have a very predictable sentence ending, you're going to have a very small N400. If you have a very unpredictable sentence ending, you'll have a large N400. But if you have something that's sort of intermediate expectancy, then you'll have an intermediate amplitude N400. Okay. Okay, and not only do words elicit the N400, but also pictures. So if you take a sentence like, the old man lay on the grass and lit his, and end it with the word pipe or with a picture of a pipe, you'll get an N400. It'll be sort of a low amplitude one because this is sort of an expected completion. These investigators, Ganas et al., took sentence frames like this and ended them either with expected words, expected pictures, or unexpected words, unexpected pictures, to compare the sorts of effects that you get. And so it turns out that both for words and for pictures, you get a larger N400 for carrot than for pipe. And there's a slightly different distribution over the head. So each graph is from a different electrode over the head. And things on the left side of the screen correspond to over the left side of the head and the right to the right. So to words, the N400 is more sort of broadly distributed, and for pictures, it's more anterior or over the front of the head. And so that suggests that you have kind of functionally common, but not exactly the same brain regions contributing to the two kinds of N400. Okay, so in the first study that I'll talk about, we asked the question, does the real-time processing of iconic gestures invoke brain processes that are related to the processing of meaning? And we operationalize this by saying, well, do contextually incongruous gestures elicit an N400-like ERP component? Okay, so to do this, we realized, well, we have to find a bunch of iconic gestures that we can show people. So we need a lot of stimuli of the sort of the same category so that we can average the response. So we said, well, where are we going to get a few hundred iconic co-speech iconic gestures? And we really wanted spontaneously produced gestures because, you know, we're interested in language in the wild and so forth. So we went to the Cogsci happy hour and we pulled speakers. Well, we pulled students out of the happy hour and we said, we want you to look at some cartoons because we're gesture researchers, and so that means we have people watch cartoons and talk about them. And so what we did was we said, we're doing a memory study. We want you to produce a detailed description of this so that another speaker could pick it out of an array. And so then we took these we took these video clips that we got of people describing cartoons, and we used them in a subsequent ERP experiment. So in our follow-up experiment, what we wanted to do was to show people a little bit of the cartoon and then a little bit of the clip of somebody describing it. And because if you could hear what the speaker was saying, you would know whether or not the description matched the cartoon you'd just seen. We showed silent clips. So we showed cartoons followed by silent video clips of speakers either talking about the preceding cartoon or a different cartoon from the same stimulus set. So that's how we got a set of congruous gestures and incongruous gestures that we could compare. Okay, so in this study, speakers would see a short clip of a cartoon followed by a silent video clip. And in this cartoon, you see the hose unwinding. And so the speaker goes like this in the congruous gesture. And this gesture is from another cartoon where a mouse is putting a ball on his nose or something like that, so it goes like that. So it's sort of unconnected to this unwinding hose. And what speakers were asked to do was just to press a button as to say whether this video seemed to go with the cartoon that came before. Since this was kind of a heavy-handed manipulation, we did a follow-up study where what people did was they watched the two different video stimuli, and then they saw a probe word, and they had to say whether the probe word seemed to be related to either of the videos that came before. So they would say yes if it was in this case where they see the cartoon and the related and the congruent gesture. They would also say yes if they saw the cartoon and the unrelated gesture. But here they would say no because watch has nothing to do with either of these or either of these. And what we're interested in is going to be their brain response to this stimulus, so before they've actually made any decisions. The question is, are we going to get an N400 response to the incongruous gestures? Okay, and so we predicted that if comprehending gestures actually recruits processes similar to the processing of meaningful images or meaningful words, then we should see an N400-like response in the brainwaves. Okay, and it turns out that in both experiments we saw what we call the gesture N450, where you see a negative peak in the brainwaves about 450 milliseconds after the onset of the video. And the response is slightly different in the case where they're making a decision to the video, but we saw the same response in both experiments. So when you explicitly draw their attention to the relationship between the gesture and what came before, and in the case where they're just being attentive to both stimuli. Okay, so that's consistent with our hypothesis that people really are treating these as meaningful stimuli. So with respect to the question and the space structuring model, so does gestural input contribute to the construction of cognitive models? The answer based on these data seems to be yes. But of course, there are a number of aspects of this study that are pretty different from normal language use, right? So people are watching cartoons followed by silent videos, so that's not very naturalistic. So I wanted to talk about, well, if there is this contribution of gestures, what might it be? So the idea is that when you're in a multimodal discourse comprehension situation, which is most of your life, right? You're getting these different inputs in these different channels, and what they serve to do is to activate information in your background memory. So in the situation with our buddies in Oregon, this guy, I think his name is Rocky, something like that. He says, he says the snake was right here, and in response to that input, you're activating information in your background knowledge about snakes. And he moves his hand in this sort of circular manner, and so that activates information about that shape. And you would employ conceptual integration processes to integrate your information about your knowledge about snakes and your knowledge about coiled things, and say, hey, a snake could be coiled, and form sort of an integrated representation of a coiled snake. So the idea is you hear the snake was right here, and the language input activates background knowledge. The gestural input activates background knowledge. And what you do is you integrate that information in order to form sort of a more visually specific cognitive model and construal of the situation that he's talking about in his narrative, where the gesture's giving you information about the relative location between the guy in the story and the snake in the story. And then the sort of circular movement that he makes gives you information about the configuration of the snake. And so then you would have sort of a more vivid cognitive model than you might have otherwise. And actually in the story, the snake scares him so much that he jumps into the adjacent river where he had been intending to go fishing. Okay, so the next study I want to talk about is address the question of whether speakers actually integrate gestural information with linguistic information. So we saw that they seem to be integrating it with information activated by the cartoon. What about with words, which is kind of more characteristic? So what we did in this set of stories was we had people watch these same silent videos of spontaneously produced iconic gestures, this guy describing cartoons, and then we followed them by a word from his discourse, just a visually presented word that was either related to what he was doing or related to a different video. And we wondered whether or not the words would be primed by being preceded by an iconic gesture that was related to them. And our dependent variable is going to be the amplitude of the N400. And so the prediction is that the N400 should be larger for these unrelated words than for these related words. And if we see a relatedness effect, that would indicate that the processing of the word was facilitated by the presence of the preceding related gesture. Okay, and that's actually what we found was we got a larger N400 for the words that were preceded by an unrelated gesture than the words that were preceded by a related gesture, suggesting the gesture actually facilitated the processing of the word that was related to it. In the first experiment, we actually asked people to say whether or not the word was related to the preceding gesture. We did a follow-up experiment where we just said, just pay attention to these stimuli. You don't have to make any decisions. We just want to see what your brain does as you watch these videos and read these words. And then at the end of the experiment, we did a surprise recognition test to see if they remembered these words so that we could throw out any people that were sort of sleeping during the experiment. And we got a smaller relatedness effect than we got before when we told people, well, pay attention to the relationship between the word and the gesture. But we still got a nice, reliable relatedness effect where the unrelated words elicit a larger N400 than the related words, suggesting they're harder to process. Okay, so this is linguistic information, but it's not actually the speech that tends to accompany these. So we thought, okay, we're going to get a little bit more naturalistic. So do speakers integrate gestural information with linguistic information in the accompanying speech? And here we wanted to address this idea that I was discussing about speakers integrating the linguistic information with the sort of analog information that's conveyed in the gestures, and whether people are actually using it to construct a more specific cognitive model. So does speech-gesture congruity affect visual processing of the discourse referent? And does gestural information actually lead you to more visually specific expectations about what's being discussed? Okay, and the reason that this might be the case is, what I've kind of been harping about all along, is this idea that language seems to underspecify meaning. So it's not that this utterance, it's actually a double door, is ambiguous, that there's bunch of entries in the dictionary and you have to decide which one applies, but there are lots of different double doors that exist in the world. And so any given utterance of it's actually a double door is probably going to pertain to a particular double door. And so if you're in that situation, really understanding what's meant by double door is going to necessitate sort of deciding between this and, say, this, or any of the other huge number of potential double doors. And so gestural information can actually help convey some of this, help specify this underspecified representation in the language. So our hypothesis is that speakers use iconic gestures to enhance their cognitive models that they're constructing in this meaning construction process. So in this clip, the speaker says it's actually a double door, and then he goes like this. And he sort of conveys with each hand is one of the doors, so that the configuration of the doors is not sort of the standard side by side, but this vertically arrayed double door. I think it might be called a Dutch door, something like that. Okay, so we suggest that listeners are integrating propositional information in the speech with analog information that's conveyed by the gestures in order to construct more visually specific models of the discourse referent. We set up a couple of different experiments to test this hypothesis. In the first experiment I'll talk about, what we did was to vary speech-gesture congruity and then test how that impacts your subsequent processing of a picture. So we had some video clips that were sort of the original video clip with the gestures that the speaker spontaneously produced with that speech. And other video clips were edited so that you had the speech from one clip along with the gesture from another clip. And then we showed people pictures of what the speaker was talking about to see if that would affect their processing of the picture. And so the hypothesis is that if you get a congruous speech-gesture pair, that should lead to better processing of the picture probe than if you get an incongruous speech-gesture pair. And in the other experiment I'll talk about, we actually varied the congruity of the picture probe to the prior discourse and tested the impact on the ERPs to picture probes. So in these experiments, we're taking advantage of prior work that's been done on the processing of pictures. So if you show people, I talked before about putting a picture into sort of a sentence context. If you show people two pictures in a row, you'll see effects of semantic relatedness on the brainwaves. So if I show you a hamburger followed by French fries, which would be sort of a related pairing, and compare that to a hamburger followed by like maybe a picture of a dirty sock, you'll get a larger response to the dirty sock than to the French fries in what's called the N300 component and then also the N400 component. And so the N400 component is sort of our old friend. It's an index of meaningful processing. And it's thought that the N300 indexes a special picture semantic component, so that it's indexing object recognition processes. Okay. Right, so in this first experiment, what we did was we took videos. So in this congruous clip, it's what the speaker produced. His face is blurred out digitally so that you can't see the fact that the sound in one case goes with his lips, and in this case doesn't go with his lips. So here he says 2 throw pillows, and he moves his hands like this, this one, this one. And here he says 2 throw pillows is exactly the same wave file, but it's paired with a video, a different video where I think he's talking about a dorm room refrigerator or something like that. And so he's making a gesture that looks nothing like anything throw pillow related. And so we want to see whether getting a congruous speech gesture pairing impacts your brain response to a subsequently presented probe picture. So subjects in the experiment saw the videos that were either congruous speech gesture pairings or incongruous ones, and then they saw a picture probe, and then they saw a word, and their task was to say whether or not this word was presented in the video. So did you hear this word in the video? So the task doesn't really draw attention to the relationship between this and the picture. It just sort of forces them to attend to the speech in the picture. Okay, and it turns out that the brain response to those picture probes was modulated by whether or not they were preceded by a congruous speech gesture pairing or an incongruous one. So you get a larger N300 and a larger N400 potential if they're preceded by the incongruous speech gesture pairing than the congruous one. And this actually wasn't the case for all our stimuli, but for the picture probes that people considered in a separate experiment to be the most highly related to what was conveyed in the video, there was an effect. So it's not as though it's sort of universal, but if people see a really tight relationship between the picture probe and what was presented before it, then having the congruous speech gesture pairing seems to make it easier to process this picture probe than having the incongruous speech gesture pairing. Okay, and so in a follow-up experiment, we wanted to use a slightly more natural paradigm. So, it's kind of, the incongruous videos don't look as bad as you might think that they do, but it's still kind of heavy-handed to put the wave file from one video with the video aspect from another video. So we wanted to use all congruous speech gesture pairings. So again, these are spontaneously produced co-speech iconic gestures. It's from sort of an artificial discourse situation of a guy describing things to a person with a camera. But they are just sort of naturally produced gestures. He didn't know that we were studying gestures. He just knew that we wanted videos of him describing a lot of things. And so what we did was we found parts of his discourse where the gesture seemed to convey additional information over that of the speech. And we got picture probes that were specifically designed to kind of test that. So in the double door example that I talked about earlier, it's actually a double door. We had 2 picture probes, one of which was a double door, where if you just heard the speech, you're like, okay, that's a double door, right? And one of which we call a cross-modal match because it matches information produced in both the speech and the gesture. So it's a double door, and if you're integrating the information in the speech and the gesture, you should see this as being a more related picture probe than this. And so that's what we're basically setting up an experiment to test. So the way that this experiment unfolds is if you're the subject, you watch a short video clip, you see a picture probe, and then you get a word, and you have to say yes or no whether this word was presented in the video clip. Okay, and we have different kinds of picture probes. So we have our 2 double doors. So this one is related to what he says. This one's related to what he says. But this one's additionally related to the information conveyed in the gesture. And then to kind of control for the visual aspects of the processing, we took each stimulus and made it an unrelated probe for a different discourse segment. So here he's talking about dorm room refrigerators, and you see a door, and same here, you see the other door. So we could sort of compare the brain response here when they're both unrelated and see if there's any basic visual processing differences between the two, and compare these two as well, so that any differences we see here should be much bigger than any differences that we see here. Okay, and so first I'll show you just sort of each door compared to itself. So this door, when it was preceded by the It's a Double Door video versus dorm room refrigerators video, and this door when it's preceded by It's a Double Door video versus dorm room refrigerators. And what we see is the effect for this door that's, we think, primed by both the speech and the gesture, is larger than the effect for this door. And also that there's this additional N400 effect, suggesting that even object recognition processes were kind of facilitated by the information presented in the gesture. So another way of looking at this information is you compare the processing of the two doors when they're preceded by the correct video versus when they're preceded by the incorrect video. So if they're preceded by the incorrect video, like the dorm room refrigerator video, they're equally difficult to process. But when they're preceded by the It's a Double Door video, the speech and gesture related probe is actually easier to process than the speech only related probe. So we think this is good information, good evidence that people really are computing a more visually specific representation of what's being talked about when the gesture, when the speech is accompanied by gestural information. Okay, so this set of studies suggests that cross-modal pictures are easier to identify than the speech-only ones, as indexed by the less negative N400 component, and that the cross-modal pictures are easier to integrate with the discourse primes, as indexed by the less negative N400 component. And it supports our hypothesis that analog information in gestures is integrated with propositional information in speech in order to form more perceptually specific representations. Okay, and so the last study that I'll talk about has to do with the question of whether or not the presence or absence of gestural information affects the real-time processing of the speech itself. And this is kind of ongoing research that we're kind of finishing up, we hope. And so again, the thing that we're faced to contend with is the fact that language is sort of underspecified, and we think that what the gesture is doing is giving speakers additional prompts to help form a more specific kind of representation. So he says, well, where there's a green parrot, fairly large, and he does this, you kind of have this image of a parrot perched on his arm. Okay, and so what we wanted to do in this experiment, as opposed to sort of focusing on how you process a picture that's presented subsequently, was to actually look at, well, what happens to the words in the speech? What does your brain do with the words in the speech when they're accompanied by gestural information versus not accompanied by gestural information? So what we did was, in one condition, we had the original video, so the guy talking about these scenes that we gave him to describe, and he also talks about other things like how to pitch a tent and how to make a peanut butter sandwich, a variety of different concrete kinds of descriptive tasks. And then in our control condition, we just showed a still image from the video that conveyed no semantic information about the topic of the discourse. So the idea is that in one condition, you're seeing gestures that are pertinent to the discourse that were spontaneously produced with them. In the other case, you're seeing a still image. So you have, a human body there, you have a face, you have hands and arms, but they're not moving. So obviously, they're not conveying gestural information. And the main thing that we were interested in was how it's going to affect the processing of the words in the speech. But since we've never done speech stuff before, we kind of included our old standby of having a picture probe. So we figured, we'll have a related picture probe and an unrelated picture probe. So if we get no effects, at least we can look at the ERPs to the picture. So what the subject sees is a little topic that tells them what the speaker's going to be talking about, since the videos are kind of go by quickly. and you see the video, or the speech is either accompanied by the video information or just by a still photo, and then you see a picture probe, and your task is, again, you see a word, and you have to say whether or not that word occurred in the video clip. So it draws your attention to the verbal content of what he's saying in our task. I don't think I have time to show you a clip, but I can show you in questions if you want. So our design included this related picture probe versus unrelated picture probe. So the first thing I'll show you is the size of the N400 effect for related picture probes versus unrelated picture probes when preceded either by gestural information or by a still photo. But then the real thing we want to look at is the ERPs to the speech. So as in previous studies, we found a larger N400 relatedness effect in the gesture condition than in the sort of still photo condition. So it seems as though having the gestural information facilitated the processing of this parrot photo compared to an unrelated, kitchen egg timer photo. And so what about the ERPs to the speech that was presented along with the videos? Well, it turns out that if you look at the lexical affiliates, so in the parrot video, he says it's a green parrot, fairly large. Really, the lexical affiliate in that case was just considered to be parrot. And then green and fairly large were considered to be non-affiliates. So for the lexical affiliates, it seems as though we're getting, we're definitely getting a different response when it's preceded by the still photo to when it's preceded by the video. And it seems to be probably an N400-like response. So that suggests that the sort of semantic integration is facilitated for the words that are presented in the context of a video versus the words that are presented in the context of a still photo. And actually, even the non-affiliates, there's sort of a small effect for them as well. So it seems as though having gestural information does help the processing of words in the ongoing speech. Of course, in one condition you have motion, and the other condition you don't. So it could just be an arousal. But I think I have evidence that the effects that we're seeing are not just an artifact of the arousal of the subject watching a video in the one case and not a video in the other case. And this comes from sort of looking at the effects on different words in the speech with relation to where the gesture is. So we looked at the words that were uttered coincident with gesture onset. And when I say gesture onset, I mean the stroke. In this case. And we see a big N400 effect, so I'll just maybe sort of focus here. So there's sort of a larger negative going response to words that were presented with the still photo than words in the video, suggesting that processing was more difficult when there was no gesture. And if you look at words that were actually uttered mid-gesture, we see kind of a similar effect that it's more difficult to process these words that are presented without gestural information than words that are presented with gestural information. But this is words that were uttered actually after the first gesture was over. And Seinfeld was a show about nothing, and this is a graph about nothing. There's kind of noisy, squiggly lines. There's no difference in the electrical activity that's elicited to the words that were presented in the video context and the words that were presented with the still photo. So if you present, so the gestures seem to be helping the words that are presented coincident with the onset and the words that are presented in the middle of the gesture, but the words that came after the end of the gesture were not facilitated by the presence of the gestural information. So the fact that there's no effect here suggests that the other effects that we're seeing aren't just the fact that they're a little more stimulated by the fact that there's a video in one case and just a still photo in the other case. So seeing no effect here is actually very nice. So to go back to where we started from, language in Oregon, I think I've shown you evidence today that the information that's conveyed in these co-speech iconic gestures does seem to engage brain processes that are involved in processing the meaning of stimuli, and also that the what the gestures are doing is helping you to take information that's conveyed in the speech and information that's conveyed in the gesture to integrate aspects of those two different modalities in order to form sort of more visually specific representations of what's going on in the discourse. So I've only talked about iconic gestures. It would be interesting to talk about some of the sorts of gestures people at this meeting have been talked about that have, so Kenzie Cooper-Ryder talked about like very complex deictic gestures that actually refer to abstract topics, or more kind of metaphoric kinds of gestures where abstract information seems to be conveyed by the shape of what people are doing, like Alan Chenke talked about some of that. So there's, seeing that there's concrete functions for these iconic gestures sort of opens up the possibility of looking at the cognitive functions of more sort of abstract gestures as well. And then the last set of data showed you that it seems as though gestures are also facilitating the processing of the speech that's accompanying these gestures, gestural information. Okay, so I'd like to thank my colleagues, especially Ying Wu, and thank you for your attention.
So we do have a little time for questions.
Uh-huh.
So I was pretty convinced in your last study that the effect wasn't the product of just video versus still, but I was just curious, it seems like you have enough data and you have a good paradigm for using video comparisons. You know, we probably produces enough, you know, self-adapters or feed gestures that you could do a video comparison. So I just wondered if there was a particular reason why you didn't. It's just the sheer labor of producing all this video.
Yeah, because you have to, well, during the speech in particular, you have to, you know, get into prod and look at the word forms and find the onsets of the words. Right, yeah, you have to blur the faces if you do that. It is something actually we're working on right now. So yeah, the idea of looking at the same videos, different words in the same videos, that's something I'm kind of interested in doing, but there's control aspects that there are different words produced when he touches himself from when he does gestures. But still, I think that's an interesting thing to pursue as well. Yeah. Mm-hmm.
It seems to me that in today's world, the PowerPoint slide has become a form of gesture. And you know, if you want to study incongruous gestures, you would put somebody else's slides on while you're giving your talk. See what happens.
I'm game. If somebody else wants to present their material with my slides, that would be good. Uh-huh.
I wonder if you mentioned having done some baseline studies for some of the stuff you did, but did you in fact check whether people thought just some of those gestures might have been related or not related? So just because it was from another video doesn't mean it couldn't potentially be construed as a related gesture.
Actually, we're kind of in the process of doing that now, sort of retrospectively, because there seem to be vast individual differences in, some people seem to attend a lot to gestures, some people attend a little to gestures, and also some people seem to attribute meaning to any gesture, and some people don't. So we see individual variability in our subjects in these studies, and we thought, well, one source of that might be how related they see the gestures to the thing. So we're trying to get some of the people back into the lab to say, I think this gesture was related, and we're also going to other people to see that. And yeah, there's variability across items and across people. So, and I think that our preliminary evidence suggests that it's not whether or not the speaker produced that gesture with that utterance, but whether or not the listener sees it as related to that utterance. So even if you have what we call an incongruous gesture because it wasn't what the guy produced, if the listener sees a relationship there, then you see the same effects in their brain as when they're congruous because they actually were congruous. So.
Just a question about your last study. Most of the studies that I know about that look at post-speech gesture with size gestures and dimensional adjectives consider the adjective to be the lexical affiliate and not the noun. And I'm just curious what motivated your decision in this case to look at the it's just idiosyncratic to this?
Yeah, no, we tend to well, we, both because they're hard to identify in the speech and because we figured there probably wouldn't be a big semantic effect, we didn't look at the function words at all. So we only looked at the content words, which narrows you to pretty much nouns, verbs, and adjectives. And we had people code what the lexical affiliates were, and they tended to consider the nouns to be, our coders tended to consider the nouns to be the lexical affiliates. And the noun seems to be usually what, sometimes the verb does, but a lot of times the noun is what's coincident with the onset of the stroke. So that was another thing that sort of, like, so in the green parrot fairly large, like we wouldn't consider green to be related because there's no way that his gesture can indicate green, right? And his gesture isn't really all that parrot-like, but in the context of the speech, it becomes parrot-like. So that's why parrot was considered. Plus, the parrot kind of comes with as he sets into that gesture. So yeah, so large is something that could have been coded as a lexical affiliate.
So yeah, so normally it's the dimensional term that corresponds to the dimensional characteristic of the gesture.
Yeah, well, some of the studies that have been done, well, in the ERP literature, have used like a really narrow range of stimuli. So they show the same video over and over again. And so they're only talking about these two objects. And so like the adjective really is the content of what he's talking about. But he's talking about real things. So often the adjective is something that it's important to him, but it's not all that important to the scene as a whole. So I think our coders were really responding to what was in there, and they weren't just noun freaks or something. Uh-huh.
Why do you think you were getting N300 responses, and do you think that any late persisting N300s made it more difficult to tell whether you were getting true N400s?
Well, people will talk about overlapping components sometimes. This isn't a case where people argue about that a whole lot. It's kind of pretty well agreed that the end of the N300 doesn't really overlap that much with the beginning of the N400. And even if it does, the N400 persists for long enough. So, I mean, there's always going to be overlap. So, yeah, I don't think there's a big problem there with, but I mean, we're interpreting the N300 effect as having to do with the fact that this genre that we're looking at is he's describing concrete objects, and the gestures are conveying visual-specific information, and so you actually get facilitated visual processing. So not low-level visual processing, because we can look at that also, but sort of information about the shape, so it enables you to recognize the object earlier. Well, one would think. Does that address what your concern is?
For just someone seeing a gesture, any gesture, about an object that in fact is not there. So you, from what you just said, you seem to be suggesting that the N300s are a response to the fact that they're gesturing and describing an object.
Well, remember the
object
N300 is
not
to a picture of what they're describing. So the person sees the video, then they see a picture of what's being described. And so you see the N300 difference on the picture. Right, so not to the gesture itself. Although we have evidence that they also elicit kind of an N300-like thing if you just show a static picture of a gesture. So you see that object, and if you've been primed by the gesture and the speech, you can kind of presumably identify what the object is easier in the case where you got the gestural information than in the case where you got misleading gestural information. Mm-hmm.
You were talking about 3 kinds of gestures, if I'm not mistaken, and you were also talking about different opinions in the field, whether they help the speaker or the see, of course. So it looks like your kind does help integrate semantic interpretations, okay? But the problem is in real time, we get them all.
Uh-huh.
And so I need to decide whether the person gesturing is now doing gesture type 1 or gesture type 2 or gesture, it can be confusing. Like I may think what you did is iconic, but in fact what you were doing is for your own lexical accessing process, whatever. So are you doing, or is anybody working on that? Not a trivial problem.
Right. Well, I'll show you, I think there's opportunity to show you one of these videos. Because, you know, I mean, we picked the sort of the gesture type that we thought was most likely to lead to a response, right? But in these videos, I think this is a good one to show. In these videos, there's not just the iconic gesture. There's other stuff as well. So there's a lot of gesture researchers here, real ones.
Those flasks, I should know the name of it, that's kind of larger at the bottom.
So I chose that because this is a case where the gesture, it's actually not helping lexical access because I don't think he knows the word. I think it's Erlenheimer flask, something. Oh, you haven't seen the flask, I have. But if you know what an Erlenheimer flask is, he traces that shape there. So this is a case, I mean, it's, you know, I'm saying it's spontaneously produced, but it was kind of an artificial situation with him talking to Ying with a camera there. But yeah, he's searching for the word and he shows you, Alan?
I was going to say, but gestures are usually multifunctional, so it's actually, I don't think it is a problem, because then you're doing multiple things at once and we don't have to categorize them and say, doing this or that. We're taking in multiple sources of information, communicative information, as well as representational information, interactional factors. Also, we're, you know, taking this in to varying degrees, consciously, unconsciously, so there are a lot of things going on at once.
Yeah, if you think about my cartoon, where I had the cognitive model in the middle and then the other stuff sort of surrounding it, I mean, we're always getting all different kinds of perceptual information, and we have to know.
I think we have to sort it out. Suppose you use something for function X, and I think it's iconic, and I'm trying to write myself the class in a way that looks like the gesture that you did for a different degree or for a different purpose altogether. So speakers coming and receives have to somehow.
But as you were saying, some people don't even pay attention that much to gestures. So,
Okay.
depends on the
Well,
individual.
of course.
Yeah, but I mean, if you look at this,
One of those flasks, I should know the name of it, that's kind of larger at the bottom.
you know, at the end, he's kind of clasping his hands, and you could be attending to that. That's not conveying any information other than, you know, sort of at the subjective level, I'm done, you know.
So I know, I'm supposed to know that it's done and not part of the shape of the flask, you know?
Yeah, I mean,
Of course we know it all, but we have to explain it.
it's a very interesting question, yeah. Yeah, so I mean, maybe you have some process that's just trying to integrate everything, and so the stuff that's less meaningful isn't going to help a lot, but you're working on it, and the stuff that is meaningful, it does actually manage to activate relevant information. So, yeah, it's a good thing to ponder. Yeah, does anyone want to see another video? I just have one more video. Oh, this isn't the one I thought it was, but it's still okay. What? Why not?
Are drawers that pull out in a box.
So yeah, he's talking about two drawers.
Drawers that pull out in a box.
Yeah, so here he's talking about pulling out, but the drawers is what's actually produced with the motion gesture. So I mean, that's another example of the noun being the lexical affiliate. Well, what we coded as a lexical affiliate, even though pulling out is what he's demonstrating, and that makes you think about what kind of a drawer affords that kind of pulling out process. So yeah, so that's probably why the quote non-affiliates like pull out are being facilitated as well, because they're also related to what's conveyed in the gesture.
I just want to say one thing, that there's another use of gesture which is in helping the listener organize abstract information. And I use that a lot in teaching. I'm a teacher. And for example, I'll say you can have the high lumen lamp or the F28 lamp. They both have, you can have your same, higher lumens for the same wattage, or you can have less lumens, less wattage and more lumens. I'm saying, in their mind, I'm creating that this is the low F28 lamp, this is the high lumen lamp. So when I'm referring to that later on in the lecture, I always say, and you can use the high lumen lamp. So it's for organizing information, which is spatially organized. I'm assisting them in doing that. And that has nothing to do with the physicality of what I'm talking about.
Yeah, actually, my colleague Tom Gunter at the MPI in Leipzig has done some studies looking at this. They call it abstract pointing, where people set up a discourse referent in one region of space, like Mickey Mouse, Donald Duck, Mickey Mouse, Donald Duck, and then they'll have an actress produce, Mickey Mouse. It's hard to do. You got to be trained to do it. So Mickey Mouse, Donald Duck, Mickey Mouse, Donald Duck, and then Mickey Mouse. And people actually have kind of an incongruity response to that you've directed them to the wrong region of space. And yeah, this is actually in some sign languages, it's sort of a formal aspect of the grammar. Yeah, so yeah, it seems as though there's something about brain organization that actually promotes this sort of spatial association with a topic. And I mean, it's probably the same thing that underlies the spatialization metaphorical tendency in general. So.
Let's thank our speaker.
Including
responses? Very brief, I promise. Thanks. So those of you who have been here through the entire trajectory of this conference from its beginning moments to now will remember that Faye Perrell began by reminiscing about how CSDL is her favorite conference, and it's my favorite conference too. And you may, this is partly because of an experience I had before I started grad school with my colleague Faye Perrell and I. Stand up, Faye, introduce yourself. And we drove down to Santa Barbara, right? Strangely, we have some of the same, oddly enough, this may sound familiar to you, some of the same reasons for having affection for this conference, but it really, it's also because this really is such a wonderful conference, and not because of the work that we were doing, but because of the work that all of you do, and how wonderful, it's really a wonderful group of people. It's a really delightful size, and sort of seeing old friends and new people who bring me into the community, and all the wonderful work that I've been seeing in the great talks, and I've been really delighted to discover that I've had the leisure to enjoy these talks. So I want to thank you, and I want to invite you to thank some of the other people who have maybe been a little bit less visible to you than Mark and Faye and I. So I'd like to thank, of course, our student volunteers. I don't know how many of them have made it, but if you could display yourselves. Thank you very much. Wonderful. And we couldn't possibly have done it without you, so thanks very, very much. I'd also like to thank Ana Brontes, who did work before you got here with expert formatting of things for the program, and was a great help and very generous with her time. And I'd like to also thank Ken Klicka, who's sitting here in the back and he's our assistant dean for facilities management, but also does research in cognitive science as well. So I think that we've really taken advantage of this motivation on his part, and he's done an incredible amount of work for us over an incredible amount of time, and has been a great help. And many of you have complimented us about how well things have worked with the space and all of this stuff. It really would not have been remotely possible without all the very hard work that he did. So thank you very much. And I don't know that she's here, but I also want to thank Jessie McGinnis, who is the departmental assistant for cognitive science, who also, I think, we took advantage of her good nature and the fact that she is very interested in the subject matter to getting me even more helpful than above and beyond the call of duty completely. Is she here? She's not here, but let's all just thank her in absentia. Also, maybe on your way out, you can deliver your thanks to Eileen Kelbach and Melissa Shoup, who are the people that you have been encountering in the cafe and the coffee breaks. Normally, they would have not been here this weekend, and they're working all this week, and their long days and wonderful good nature has been really lovely for us. And again, this wouldn't have been nearly as nice without them. So I'm going to have us clap for them, but if you happen to get a chance to thank them on your way out, that would be fantastic. So. And finally, I really want to thank all of you and sort of as a proxy for the rest of all of you who aren't here anymore, because it really, I mean, I love this conference, and I really love this conference, and I really loved this one, and it's because of all the wonderful talks that you did and all of the wonderful community among all of you. So I really want to thank all of you for making the CSDL really great as well.